Okay, welcome back to Physical Science Online. Today we got some notes about parts of the atom and periodic trends in general. So I'll just jump into it. I'm hoping to get this done in 2 videos is kind of my goal. Parts of the atom, pretty straightforward. Here's your chart. This is straight from your book. I just converted it over into a Google Doc for you. Some things you need to know about each part of the atom. 3 parts that you need to know about are protons, neutrons, and electrons. The proton and the neutron are both located in the nucleus. The electron is located in the electron cloud. That's sometimes you can think of electrons as like orbiting around a planet, but that's not quite right. They more kind of randomly go around in a cloud around the nucleus. Symbols always really straightforward. Protons P, neutrons N, electrons an E minus, always just to signify that it's negative. Mass, proton and neutron are both 1 atomic mass unit, so they have a mass of 1. And it's not that the electron doesn't have mass. It's just that its mass is so small, we call it 0. It's not on the same scale as the other two. It's just so tiny that we don't count it. And finally, their charges, protons are positive, positive, neutral, neutron, 0 charge. And then electricity is negative because it electrocutes you. Ha! So there you go. Charges, parts of the atom. One thing you need to be really familiar with in this class for the second half of the semester is how to read a square from the periodic table. This chart gives you a really good breakdown of everything that you're going to be needed to know, what it is, a definition of it, how to calculate it, stuff like that. You might even want to take more time on this particular slide than I go over. So symbols, pretty straightforward. There's a name and a symbol for every single element. Atomic number, you really do need to remember that the atomic number, which is normally at the top of a square, but not always look at your key, is the number of protons. What gives an atomic element its name is the number of protons. As soon as you change the number of protons, you are a new element. You are a different element if you have different numbers of protons. Atomic mass, though, is this average. So you always see these really long numbers after the atomic mass, these really long decimal places. That's because different in nature, different abundances of, let's say, carbon-12 and carbon-13 exist. And obviously, it's really close to carbon-12, so there's probably more carbons with 6 neutrons. The atomic mass is an average of the mass numbers, which is protons plus neutrons. So there's way more carbon out there with 6 neutrons than there are with 7, but there's still some out in nature that have 7. And that's where that decimal place comes from, is because it can exist with different numbers of neutrons, but it cannot exist with different numbers of protons. And we always round that mass number to find the most common, or atomic mass, to find the most common mass number. Mass number is just the sum of neutrons and protons in the nucleus. We can use all this information then to draw the atom. Hopefully from your book reading, you got the sense that there is no perfect model of the atom. Each model serves a purpose. That it just really doesn't exist to have that perfect model of the atom. And some of them are really hard to draw. Even though the electron cloud is touted as the best model, it is really hard to draw. So you just need to know how to find the parts of the atom, the atomic number, the atomic mass versus mass number, valence electrons, charge of the element, yada, yada, yada. And then you need to be able to come up with your model. I don't even know why I throw the Bohr model in here other than that it's the way a lot of people envision it, with these electrons orbiting around the nucleus and the neutrons and protons, but that is not a very good model. Instead, we're going to use something that the pure high school teachers came up with, so you will not find this anywhere else in the world. We call it the fried egg model. So we still have this nucleus where you're going to put your protons and neutrons, and then we have this cloud. So that's what forms the egg part of the fried egg model, a nucleus and a cloud, where you're going to throw your electrons, and then you're going to make sure to take out